Welcome to Spring LIB.
Okay, in this problem in part A, we have to normalize the wave function. So we have the wave function as psi x 0 equal to a psi 1 x, which is the first component of the x stationary state, plus uh, psi 2x, second component of the x stationary state. So to normalize, uh, we we can write it as psi steric x and 0 into psi into x 0 dx, which is equal to 1. So this is again a. So we can write it as mod of a square into psi 1 x plus psi 2 x steric into psi 1 x plus psi 2 x dx. Therefore, a mod into this become psi 1 x square plus psi 2 x square plus psi 2 steric x psi 1 x plus psi 1 steric x into psi 2 x dx. So this is equal to 1. This is again equal to 1. These two wave functions are orthogonal, so that's why they are equal to 0. So we can write it as mod of a square into 1 plus 1 plus 0 plus 0. So we can write mod of a square is equal to 1 out of 2. So therefore a equal to 1 out of under root 2, which is the value of a. So we can write the wave function psi x equal to 1 upon under root 2 into psi 1x plus psi 2x. So for part B, uh, a wave function is given as psi x t equal to summation I equal to 1 to n, or 1 to n cn, which is the constant, into the wave function for the n stationary state into ex into e raised to the power minus iota so ex e minus iota e t out of h cat. So if for t is equal to 0, wave function look like this: is psi x equal to summation I equal to 1 to n into cn psi n x. So therefore this is equal to 1 upon under root 2 into psi 1 x plus psi 2 x equal to summation I equal to 1 to n into c n psi n x. So comparing the coefficient, we get is c1 equal to 1 upon under root 2 and c2 equal to again 1 upon under root 2, c3 and c4 are equal to 0. So this become the wave function psi into x t equal to 1 upon under root 2 psi 1x e raised to the power minus iota e t out of h cut plus psi 2x into e raised to the power minus iota e 2t. This is even out of h cut. So as we know that the energy En is equal to, for n state, is equal to n square pi h cut square out of 2 n a square. So this become n square omega. This term is equal to omega, sorry, into 1 out of h cut. So this whole term is equal to omega. So this become n square omega. So therefore the wave function psi into xt equal to 1 out of under root 2 into under root 2 out of a sine into n pi out of a x e iota omega t plus under root 2 out of a sine into 2 pi out of ax into e raised to the power minus iota 4 omega t. So therefore this can be written as psi xt equal to 1 upon under root a into sine into pi by a x e raised to the power iota omega t plus sine into 2 pi out of a x e raised to the power minus iota 4 omega t. We also need to find out the probability density. So to find out the probability density, we can write the wave function as psi steric xt into psi into xt equal to 1 out of a into sine into pi by a x e iota omega t plus sine into 2 pi out of a x into e iota 4 omega t into sine into pi by a x e minus iota omega t plus sine into 2 pi out of a x e minus iota 4 omega t. So this e and e raised to the power iota omega t will cancel. This and this will get cancelled. So we get 1 out of a sine square into pi by a x plus sine square into 2 pi by x plus sine into pi by ax into sine into 2 pi by ax multiply by e iota 3 omega t plus e iota minus 3 omega t. So this is equal to 3 cos 3 omega t. So therefore we can write it as 1 out of a sine square into pi by ax plus sine square into 2 pi by ax plus 2 sine into pi by ax into sine into 2 pi by ax cos into 3 omega t. So to find out the expected expectation value x, we know that the expectation value x is equal to integral from 0 to a x into psi into x t square dx, as we have calculated the value. So we will put in this integral, so this integral become 0 to a x sine square into pi by ax dx into 0 to a x sine square 2 pi by a x into 0 to a x sine into pi by a x sine into 2 pi by a x and dx. So to solve such a length integral, it is a difficult process, so we break it and solve it. So let k equal to pi by a, then above integral reduce to 0 to a, and this x into sine into k x dx. So therefore we can write this as integral sine square kx dx, as we know that uh, this can be written as integral 1 minus cos into 2kx out of 2 dx. So this become x out of 2 minus sine into 2kx out of 2 uh, 4k plus c. Therefore above integral which is 0 to a x sine into kx dx equal to x into x out of 2 minus sine 2kx divided by 4k as the limit from a to 0 minus 0 to a into x out of 2 minus sine 2kx divided by 4k into dx. So substituting the value, we get it as a square out of 4 minus a sine 2ka out of 4k minus x square out of 4 plus cos 2kx out of 8k square and the limit from 0 to a. So this can be written as a square root of 2 minus a sine 2k out of 4k into a square out of 4 plus cos 2k a out of 8k square minus 1 out of 8k square. So this can be written as a square out of 4 minus a sine 2ka out of 4k minus cos 2ka out of 8k square minus 1 out of 8k square. So put k equal to pi by a in above equation. We get it as the integral I equal to a square out of 4, and putting k is equal to 2 pi by a, we get I equal to a square by 4. So both the integral are same, so now we have to find out the integral, the other integral, which is equal to, so we have another integral which is 0 to a x sine into kx sine into kx into sine into 2kx dx. So as we know that we have a formula which is equal to sine a sine b equal to 1 out of 2 cos into a minus b minus cos into a plus b. So we use this formula in above integral. So this become 0 to a x into 1 out of 2 cos kx minus cos into 3kx dx. So therefore this become equal to 1 out of 2 into x into sine kx out of k minus sine into 3kx out of 3k, and the integral from 0 to a, limit from 0 to n, and then integral from 0 to a into sine kx out of k minus sine into 3kx out of 3k into dx, and this integral is equal to 1 out of 2 into a sine ka out of k minus sine 3ka out of 3k minus the integral. So putting k is equal to pi by a in above equation, we get this equal to 0. This whole term is equal to 0, and this 0 minus the integral. So now we calculate the integral, which is equal to 0 to a sine into 3k x out of 3k minus sine kx out of k into dx. So this become equal to minus cos 3kx out of 9k square plus cos kx out of k square, and the limit is from a to 0. So for k is equal to pi by a, this is equal to minus cos 3 ka divided by 9k square plus cos ka out of k square minus into 1 out of 9k square plus 1 out of k square. So this is equal to 1 out of 9k square minus 1 out of k square plus 1 out of 9k square minus 1 out of k square. So this is equal to minus 8 out of 9k square. So finally the expectation value x is equal to 1 out of a square out of 4 plus a square out of 4 plus 2 into minus 8 a square out of 9 pi square. So this expectation value is equal to a out of 2 into 1 minus 32 out of 9 pi square cos into 3 omega